Welcome back, students. Once again, we are continuing our previous lecture topic, that is oxygen hemoglobin dissociation curve. So, thank you so much for the last lecture, your patient comments, your hearing, and I have gone through your suggestions. So, Physiology Hub by Dr. Dilip Swain is a platform where learning should be there with consciousness. So, I am really happy that you people are thoroughly observing my lecture videos and suggesting me that what you need really for your proper understanding as well as more efficacy in the process of learning. So, in this, I will take care of that. Coming to my lecture, the previous lecture was Introduction to Oxygen Hemoglobin Dissociation Curve. I introduced the term, and then when I was leaving the class, I said that from the next class, we will directly draw the graph. So, let us begin the class with this graph where we will explain that why this is a sigmoid graph. This is number one. Number two, what is right-sided shifting, what is left-sided shifting, how this graph is plotted, and what do you mean by P50 value. So let us start with this word P50, because on this basis I will completely dependent on this word to plot this graph. P50 means, here P stands for partial pressure, 50 means this is 50% saturation. So here both these words are there. So I can define this that partial pressure of oxygen at which hemoglobin so 50% saturation. So this is the definition of P50 value, and this P50 value plays a very important role in deciding the nature of the plot, association of oxygen with hemoglobin, dissociation of oxygen from the hemoglobin, that means oxygen delivery. Students must understand that oxygen can only be transported to the tissues when it is combined with hemoglobin. And if it is not combined with hemoglobin, no oxygen can be transported except the dissolved form in plasma, that is 3%. So that's why loading and unloading are critical determinants of oxygen transport as well as oxygen delivery. And here this curve depicts that scientifically. With this word P50 value, it clearly says that at what partial pressure of oxygen, hemoglobin is 50% saturated. Its answer is, it varies, but yes, for this class we have taken the P50 value as 26 mmHg. Means if the oxygen partial pressure is at 26 mmHg, then hemoglobin and oxygen, another way I can say, hemoglobin shows 50% saturation with oxygen. So this is the first point of this class. Then coming to the next, if, now the point to be noted, if the P50 value increases, P50 value decreases. Suppose I will say the P50 value is 35 mmHg. Suppose I will say, what will happen? What it indicates? Or if I will say that P50 value is 15 mmHg, because I know that the normal P50 value is this one. So if I am saying the P50 value is 35 mmHg, whether it indicates that the affinity of hemoglobin for oxygen is decreasing or increasing, is it a phenomenon favoring loading or unloading, or you can say binding, non-binding, dissociation, that means, or what is the meaning of a lower P50 value. So friends, it's a very common thing that when the P50 value is increasing, that means it clearly says the affinity of hemoglobin for oxygen is a decrease. This is the take home point. That means I can say the reverse. Here I can say the affinity, if it is lowering, the affinity of hemoglobin for oxygen is increasing. So this is our second point of this lecture. This is the first point. I said what is P50 value, and now I am saying if the P50 value is increasing or the P50 value is decreasing, then what is the meaning of that? Second, now coming to another two important words, and then we will start plotting this graph. That this point is important. What do you mean by loading? What do you mean by unloading? These are another two common words which are very commonly used in Odyssey. Loading means it is the saturation of hemoglobin with oxygen. It means it pertains to binding of hemoglobin with oxygen. Exact meaning. That means loading favors the transportation of oxygen from the pulmonary, that is the lungs, pulmonary system to the tissues. That is the meaning. So you have to remember that. When I am using the word loading, means I am saying it is HB408. That means, or in a layman language, this is known as HBO. That means hemoglobin and oxygen are associated. And when I am using the word unloading, it means this HB and O2 now becoming HB and oxygen. The oxygen is separated from the hemoglobin so that this oxygen will be delivered to the tissues. So friends, always remember this concept, because students usually get confused by different types of concept, that what is loading, what is unloading, what is binding, what is dissociation, what is association, what is tensing, what is relaxing. Sometimes this loading is also known as a tensing. That means the hemoglobin is tensed, and unloading means here it is a case of relax. So you can see the outcome of this loading is the oxygen transportation from the pulmonary system to the tissues. And when I am using the word unloading, means I am saying that the hemoglobin is dissociated from the oxygen, and oxygen is now free enough, and that is going to be entered to the tissues for its cellular utilization. Now the third aspect, the second aspect is over. The third aspect is, now question arises, when loading will occur, why loading will occur, and how loading will occur. Similarly, unloading, how, where and why. Always, being a student, you must have 3 to 4 queries in your mind, because you are understanding physiology. And in physiology, when you are trying to understand your body processes and the body events, you must have these questions. Why this is occurring? If it is not occurring, then what is the output? How it is occurring? Who are the structures, who are the cells, who are the elements who are favoring this? Who are not favoring this? If it will not occur, what will happen? And if it is occurring, then who are supporting that process? And the last point, what is the physiological outcome? Physiological outcome means what is the significance? So how our life is being living, how our cells are being said to live, this is determined by these physiological events. And if oxygen is loaded, that is not important. Important is that if it is loaded, it should also be unloaded. And then the life cycle of the oxygen will be completed. So that's why it is imperative to know that how oxygen is loaded, where it is loaded, and how oxygen is unloaded, and where it is going. And what is the significance of all these events. No cell is there, remember this, no cell is there which can sustain, survive or carry out its life processes without oxygen. So therefore, the loading will directly decide that how much of oxygen is going to available to our cells. So this is the second aspect I am putting into this. So in this lecture we discussed P50 value, we also discussed loading and unloading, and now I can say there is another point, this graph. So let us plot this graph first and then we will discuss what are the modalities of this graph, how this graph is said to be left side, what is said to be right side. Let's see it. Let's plot this curve. So this is a biaxial curve. And now listen very carefully because this is very interesting, as well as this is purely physiology. So you can see here, this is x-axis, this is y-axis, this is partial pressure of oxygen axis, which is expressed in terms of mmHg. It is increasing while you move up to the x side. This is hemoglobin saturation, and I am expressing in terms of percentage. This is increasing this side, this is increasing that side, this is y-axis, you can say this is x-axis. I can plot another one, but for the time being no. So I will start from here, 0, I can go 10, 20, for me 26 is important, so I am taking 26, then 40, then 60, then 75, then I am taking 95, then I am taking 100, for example. So these are the partial pressures of oxygen, and I am reaching up to 100, but I can go up to 110, 120, 130, 140 like this, but for the time being, suppose 100. Here it is 10, then it is let it be, this is 40, this is 50, this is 6, this is 75. I am changing the axis, you can see, but it should not be, it should be uniform. But for this class I am just changing. Suppose this is 90, this is 97, and this is 100. So why I have taken these digits I will clarify in my next lecture. But for the time being, there are three very important factors are required. By virtue of this, I have selected this data. One is very important, this 50% value, this 50, because we have started this lecture with the word P50. And then the most important another one, that is this 26 partial pressure. So if I can draw a perpendicular to here and then a perpendicular to here, that is defined the P50 value. At 26 mmHg of oxygen, hemoglobin shows 50% saturation. So that is what I was interested to show you. And from your respiratory knowledge, you know that in case of veins, the maximum partial pressure of oxygen goes up to 60 to 75. Here it is 75. The maximum partial pressure of oxygen in the arteries, it goes up to the 95 mmHg. So for me, this 95, this 75, this 60, this 40, these are important, because in none of the vein in mammalian system can go up to 75. It remains the oxygen, the partial pressure of oxygen in the vein. This is an important point. It remains at 40 mmHg. Just remember this. And this partial pressure of oxygen in artery, this is go up to 95 mmHg, and we never achieve more than this in naturally in the body. In the mammalian system, this is venous is 40, and then oxygen in artery is 95. Here we have achieved 50% saturation. That means P50 value is 26 mmHg. Then P, this point is important, 75% saturation. P75 is 40 mmHg. These are the data which I need to share with you all so that you can remember. Then P, partial pressure of 95, then the saturation goes up to 97 rather, because this is the maximum percentage of saturation, and that is the partial pressure is 95 mmHg. So these are the three data which always come in the examination also. I am once again saying P50, that is 26 mmHg, P75, this is 40 mmHg, and P97, 97, not 100, 97, that is 95 mmHg. So that's why I have made my curve in that way, so that I can well explain to you people that 50 I have taken 70, I have taken 97, and for you all another that I can say, if you say 100% saturation, then the partial pressure will become 140 mmHg, which is not possible in the normal body, physiologically relevant body under normal conditions. That's why I have not drawn this 140 this side, and here it is 100, it means 100% saturation, because 100% saturation is not observed in the body. So this is my third aspect of this class. Then the fourth aspect is, if I can just draw like this, it goes very slowly, then it comes rapidly, and then almost it is getting constant. So this is actually the phenomenon. One minute more, I can show you. Suppose by definition, you can go, then we'll draw the graph. The definition is, with increase in the partial pressure of oxygen, there is increase in the saturation percentage. So the curve must be a straight line like this. The partial pressure is increasing, and here also the percentage is increasing, but it is not like this. So if it is not like this, then how it is said to be a graph which is just like said to be a sigmoid one. So this is important. So I will erase this one now, and I will draw another graph which is really scientific, more scientific. This is for concept. When we are drawing concept, I cannot hold a control over the chart exact at that point to show you. So what to do, now we will draw another graph where we will only show these three aspects, because these three are the very important, and we will show a sigmoid graph. So when I am drawing this, we can see, so these are all conceptual points for this graph. So let us draw another graph where this sigmoid shape is relevant. So this is y-axis, percentage saturation of hemoglobin, this is x-axis, and here it is partial pressure of oxygen. So I start with this, it goes, it increases, and it becomes an S-shaped and sigmoid, and plateau is achieved. So for me, this 26 mmHg is important, and where I will show there is 50% saturation is there. Then I will show the 40 mmHg, where I will say that there is 75% of the saturation is there, and then I will draw 95 mmHg, where I will say it is 97% saturation. So this is hemoglobin saturation in percentage, and this is in partial pressure of oxygen, this is in mmHg. So when you are drawing, you also understand why you are drawing in that way. What is the biochemical basis of this affinity? Why there are three phases, lag, log or exponential phase, or a first phase, and then there is a parallel. This is our next lecture. But for this lecture to complete, at 26 mmHg, the saturation is 50%. At 40 mmHg, the saturation is 75%. At 95 mmHg, it is 97% saturation. So students, with this lecture is over. Get ready for the last lecture on this, that is oxygen dissociation curve, where we will understand that when the curve is drawn like this, when the curve is drawn like this, that means this is known as right side shift, and when the curve becomes like this, then this is known as a left sided shifting. So we will understand this, and what is the transition between this left and right, that is this one, this middle, the actual one, the sigmoid one. So I can say that this is a sigmoid curve, or it is an S-shaped curve, and when it shifts towards the right, what happens? When it will shift, what is the significance? And when it goes towards the left side, what is the meaning of that? High temperature, high CO2, decreased pH, high altitude, increased 2-3 dpg. These are some of the parameters which cause the graph to shift towards right. When the shifting is towards right, that means you are going towards the unloading. That means hemoglobin and oxygen will be unloaded. Oxygen will be delivered to the tissues. That means this represents the tissue side. And when it comes into the left side, it is showing association or loading. That means the affinity of hemoglobin for oxygen is quite more. And that pair is showing that that is loading. So this side is loading, this side is unloading. So this will give rise to another two words, Bohr's effect, Haldane effect. So here I will say what is Bohr's effect, because Bohr's effect is directly related to the delivery of oxygen. So we'll see that how carbon dioxide is determining the unloading so that the oxygen is delivered into the tissues. So with this lecture is over. Thank you so much. Once again to all of you, go through this lecture. Let me know if you are having any conceptual issues. Write it down in the chat. Do not forget to subscribe and share my channel and like if you are liking my lectures. And please do not forget to put your suggestions. I always need good suggestions from the learners so that I can change in that way my presentation and lectures will become more effective. So thank you so much. Have a wonderful time ahead. Let's meet in the next lecture. Thank you so much.